Assalamualaikum to Dr. Nur Sohana. We are from group number 2 and we'll be presenting about the waste management for the production of bioethanol. The National Biofuel Policy of Malaysia seeks to include biofuel as one of the country's 5 energy sources, and so to enhancing the nation's wealth and being. As in 2011, the government of Malaysia introduced the National Biomass Strategy 2020 as an innovative approach to aid biofuel production. The National Biomass Strategy 2020 aims to build higher value-added economic activities based on the biomass that will contribute to Malaysia's gross domestic product and also provide Malaysians with high-value employment opportunities. In order to reduce the amount of greenhouse gases that are released, the Malaysia National Biomass Strategy in 2022 recommends adding a minimum of 10% bioethanol to gasoline by the year of 2020.
Assalamualaikum and good morning to our lecturer Dr. Sohana. I am Nabila binti Jai. So today I would like to talk about the potential waste in our bioethanol plant. First of all, there is three types of waste that produced by our plant, which is liquid, gas, and solid. First of all, I would like to talk about the liquid gas. The liquid waste. The liquid waste was produced by the equipment which is distillation column and rectification column. The waste product that we receive, which is cellulose, hemicellulose, lignin, ash, glucose, xylose, yeast, medium, ethanol, and water. The second waste that we get is actually the gas waste, which is it was produced by the equipment fermenter, and the waste product, which is carbon dioxide. And the third waste that we get from our bioethanol plant is actually solid waste, and we can get the solid waste from the equipment, which is what we call as decanter. And the waste product is lignin, Saccharomyces cerevisiae, cellulase, glucose, and xylose.
There are 4 total of acts and regulation covers, which is the Environmental Quality Act of 1974, Environmental Quality, which is Industrial Effluent Regulation 2009, the Environmental Quality Clean Air Regulations 2014, and the Environmental Quality Schedule Waste Regulations in 2005. These 4 regulations cover for all waste generated in the bioethanol production. This figure shows the fifth schedule with the acceptable conditions for discharge or effluent or industrial effluent or mixed effluent with standard A and standard B condition. This condition will be matched with our calculation for the mass balance and the design later on.
Assalamualaikum to Dr. Narsahana. My name is Nilis Nashariza and my discussion will be on the impacts of the waste generated from the plant to the environment. First is on the impact of liquid waste. So the wastewater produced by the bioethanol production plant mostly consists of unreacted sugar which derive from the hydrolysis process, such as glucose, dead yeast, or leftover yeast from the fermentation process. Fermentation byproducts such as glycerol and ethanol in the distillery spent wash. So most of these elements will dissolve in water and contaminate the water. A huge volume of wastewater released by bioethanol production industries contributes significantly to water pollution since the effluent contains a high number of solids, biological oxygen demand, and chemical oxygen demand. So, the water contains minerals like chloride, sulfate, nitrate, calcium, and magnesium. So, the rapid depletion of oxygen content in the water caused by the wastewater from the plant will endanger aquatic life by interfering with the survival of aquatic flora and also fauna. Okay, so fermented sludge, which is also known as the yeast sludge, is the major source of wastewater in ethanol distilleries. So this discharge effluent from the bottom of the fermenter contributes to the pollution, which contains high organic matter content. So the spent wash in the ethanol distillery is also the source of the wastewater, which exhibit an organic content which feature it a deep dark brown color. So a color causing pigment resulted from a colorant of spent wash is mainly caused by melanoidins. Melanoidin is an organic content from the spent wash cause the water bodies to be blocked from the sunlight. So the blockage of sunlight into the water can cause numerous environmental impact, which initiate from the reduction photosynthetic activity and oxygen concentration. Okay, next is solid waste. Okay, the remaining biomass, which contains yeast cell, enzymes, and solid components such as lignin, hemicellulose, and cellulose, will be discarded as solid waste from the bioethanol production. So with the alarming high disposal rate of biomass, the disposal, utilization, and management issues are the most challenges faced by the cities, especially in developing countries. This is because a serious pollution problem increases when the majority of biomass waste are left in the field to naturally decompose or discarded in landfill, which not only have low efficiency but also lead to severe environmental pollution like greenhouse gas emissions and also air quality deterioration. Okay, next is gaseous waste. So gaseous waste, which is carbon dioxide gas, is produced during the fermentations of sugar to ethanol, which happens at the fermenter. So carbon dioxide is an important greenhouse gas, but a high amount of greenhouse gas can pollute the environment. Other than that, when the level of carbon dioxide is high, the emissions of carbon dioxide to the atmosphere will affect human health as well. This happens when carbon dioxide displaces oxygen and causes humans to have difficulty of breathing. Other than that, the formations of smoke is contributed from carbon dioxide, which indirectly impacts the more visible form of air pollution. So a high level of carbon dioxide emission also can cause global climate change. One of the most direct results of global climate change has been the rise of sea level, the melting of polar ice cap, and also flooding in coastal regions. Major weather events are greatly affected by the global climate change, such as hurricanes. So the severity of this event can only get worse if there is no action taken by the higher power to stop climate change. Other than that, the aquatic life can also be impacted. This is by the nature where the changing sea temperature might make the fish to migrate to colder region.
Assalamualaikum, my name is Noamnani binti Muhammad Alami and I will be presenting on waste treatment strategies. Waste treatment strategies can be divided into three categories, which are liquid, solid, and gas waste. Essentially, wastewater treatment methods consist of physical, chemical, and biological methods aimed at removing pollutants and using water resources for various applications. Industrial wastewater treatment system for liquid waste are classified into three types, which are primary treatment, secondary treatment, and advanced treatment, which is tertiary processes. For solid waste, Quality Alam Waste Management Center has been selected as a solid waste management facility, and the solidification plant will be used as a service and facility. Lastly, as for gas waste, carbon dioxide waste treatment method is the primary method to reduce carbon dioxide emissions from large industrial sources.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifan Afi bin Matzaki. I will continue this presentation with the conceptual design and sizing for the wastewater treatment plant. So the total equipment used for our wastewater treatment plant is 7 equipment, which is the first one is the screening equipment, followed by the grid chamber, then the oil and grease trap, then followed by coagulation and flocculation tank, and then the primary clarifier, and then the aeration tank, and the last one is the secondary clarifier. The first process for our wastewater treatment plant is the screening process. So for sizing of the screen, we need to calculate the size of the size for head loss of the screen. So this this is the formula for calculating the head loss. Then we have calculate the head loss by using the formula and we get around 0.19 meter. On the left figure shown is the conceptual design of a screen. I get it from NetSolWater 2020. So the A shown on the figure is the screen, then the B is the pipe, the C1 is the bypass. Then after screen we have the grid chamber. This grid chamber is used to separate the grid particle from the wastewater, and then the fat oil and grease also separated on the top of the grid chamber. The sizing for grid chamber is we need to calculate the width, the diameter and the length of the grid chamber. So the first one, we need to calculate the area of the grid chamber, which is by using the ratio by width times length. We get the ratio of 1.5 W square. We use this formula to calculate the area, which we get around 1.9 to 76 exponent negative 3 meter square. After that, we get the width and the diameter 0.036 and the diameter is 0.054. Then the TD of the grid chamber is 2.7 seconds. In conclusion, we get the grid chamber size. The size of grid chamber is with the width of 0.036 meter, the diameter with 0.054 meter, and the length of the grid chamber is 0.81 meter. Then the third equipment in the wastewater treatment plant is the oil and grease trap. This oil and grease trap is used to remove the grease from the wastewater. So the sizing for the oil and grease trap is by calculate the oil droplet rising velocity. By using this formula, we get the oil droplet rising velocity with 0.00187 meter per second. Then we need to calculate the area, the minimum separator horizontal area. Then we get 0.31 meter square, the area of the oil and grease trap. Then we have the coagulation and flocculation tank. Coagulation tank is used to destabilize the colloidal particle by introducing the coagulant into the tank. Then the wastewater will enter the flocculation tank to agglomerize the destabilized particle into microfloc. Then the microfloc will enter the sedimentation tank for the floc to sediment at the bottom of the tank. So for the sizing of the coagulation tank, we need to calculate the Q design, which we have get around 4.164 meter cube per hour. Then the volume of the coagulation tank, we get about 0.1041 meter cube. So then for the flocculation tank, the Q design is same as the coagulation tank, which is 4.164 meter cube per hour. And then the volume of the flocculation tank is 3.123 meter cube. 48 meter per day, and the TD is lower than average flow, which is 2 hours. Then we have the aeration tank. The aeration tank will provide oxygen to bacteria for treating and stabilizing the wastewater. Oxygen is needed by the bacteria to allow biodegradation to occur. Then the supplied oxygen is utilized by the bacteria in the wastewater to break down the organic matter containing carbon to form carbon dioxide and water. So then for the sizing of the aeration tank, we need to calculate the volume of the aerated tank by using this formula. Then we get the volume around 82.2 meter cube. Then for the hydraulic retention time, we use this formula to we have get around 1.096 day. So for the FM ratio, we get around 0.87 per day. So on the left figure shown is the conceptual design of aeration tank. We have the air compressor, the influent, air diffuser, and so on. Last but not least, the final equipment for our wastewater treatment plant is the secondary clarifier. The sizing for secondary clarifier that we need to determine is the diameter and the volume. So for the first step, for determine the diameter is by calculating the surface area of a flow rate, which we have get around 20.37 meter square. Then by using the proposed diameter of 5.5 meter, we have get the surface area with 23.76 meter cube. Then, for the volume of the secondary clarifier, the detection time is 2 hours with the design flow rate of 50 meter cube per day. Then, we have calculated the volume of the secondary clarifier. We have get 100 meter cube. Then, by using the proposed size of clarifier, so the effective volume is 55.83 meter cube. So this is the cylinder volume. For the cone volume, we have get the 23.16 meter cube. So the total effective volume for this clarifier is 78.99 meter cube. Therefore, the hydraulic retention time is 2 hours 32.33 hours. So this is the conceptual design of primary clarifier from Magnis Corporation 2010.
So this is our PFT, which is bioethanol waste treatment plant, and as we can see, the first influent that going into is the screening, and then it's going to the grid chamber, moving on to the oil and grease trap. After that, they are going to the equalization, coagulation, and flocculation tank. After that, it went to the first clarifier, which is the primary clarifier. Then it's going to have the aeration process, which is happen at aeration tank. It's going to the secondary clarifier, and it went to the sludge holding tank. After that, it's going to the filter press, and we have the sludge keg, which is, I believe, it's safe to release to the environment, and it's actually the effluent, the discharge has no effect to the pollution.
So, in a conclusion, production of bioethanol from lignocellulosic biomass had produced all types of waste, including liquid waste, solid waste, and also gas waste. There are several approaches that have been proposed as a solution in managing the waste produced by the production. Solid waste. For the solid waste, Quality Alam Management Center will be used to manage the solidification plant. Carbon dioxide waste treatment had been chosen to dispose the gas waste. And for the liquid waste, the standard industrial effluent treatment system IEATS that consists of primary, secondary, and tertiary treatment had been applied. The design and dimension of major equipment and tank in the EITS, such as screen, grid chamber, oil and grease trap, coagulation, flocculation tank, primary clarifier, aeration tank, secondary clarifier had been calculated and could be utilized as a reference in the development of waste treatment plant in the production of bioethanol. There are also several recommendations could be applied in order to optimize the IATS for the waste treatment plant. The usage of organic derivative coagulant should be explored in the coagulation flocculation process, since various challenges have arisen during coagulation and flocculation, which owing to environmental health concern with the use of inorganic coagulant. The key to efficient wastewater treatment plant management is process optimization, which may be accomplished by pursuing ideal process conditions such as SRT, aeration rate, and ethanol recycling flow rate. Hence, the implementation of a modeling approach could be used to find the optimum solid retention, which is SRT, of wastewater treatment plant, which minimize operating costs as well.